Find the exact value of the expression. Hint, sketch a right triangle. So for this one, we're finding secant of arc sine. So remember, arc sine is only going to exist from negative pi over 2 to pi over 2. But since sine is positive here, we know our angle is going to fall in this quadrant. So from our problem, we know that theta equals arc sine of 4/5. Sine is opposite over hypotenuse. So that means this side is, this opposite side is 4, and my hypotenuse is 5. So if I am looking for secant of theta, I need my hypotenuse over my adjacent. My adjacent equals the square root of 5 squared minus 4 squared. My adjacent is 3. So therefore secant theta is 5 over 3. For cotangent, or I'm sorry, for arctangent, remember arctangent, just like sine, falls between negative pi over 2 and pi over 2. But we're looking for where tangent is positive, and that is going to be in this quadrant only. So here's my sample triangle. I know that theta equals arc tan of 5 over 8. Tangent is my opposite over adjacent. So that means opposite is 5, adjacent is 8. I am looking for cotangent theta, which is adjacent over opposite, which I already have in my picture, 8 over 5. Now I'm looking for secant of sine inverse negative square root 2 over 2. So remember, sine inverse falls from negative pi over 2 to pi over 2. But since it's negative, I know my angle is going to fall down here in this quadrant. So I know theta equals sine inverse of negative square root 2 over 2. So for sine, that is my opposite over my hypotenuse. So negative square root 2 over 2 means that this side has to be negative square root 2, and my hypotenuse is 2. So I'm looking for secant of theta, which is hypotenuse over adjacent. So I need to find this side. Adjacent equals square root of 4 minus 2, which I get by doing 2 squared minus negative square root 2 squared, which is 4 minus 2, which is square root 2. So this is going to be 2 over square root 2, or 2 square root 2 over 2, which is square root of 2.